Hello students. So this is the sixth lecture of motion chapter. Uh, with very crystal clear I am going to discuss all the things. This is why this video lecture is going lengthy, but fact is that if you learn, if you watch all this video carefully, you will get the idea how motion chapter works. Okay, means how we can deal with all the problems, because I am discussing all the things in very clear way. Okay, very clear way. If you are watching all the videos from the beginning, you can feel the things. Now let's start with the chapter, means with the topic graphical representation of motion, class 9 motion chapter. Very much important part this is, because I am going to recall all the things which you know in the previous lectures, like distance, displacement, speed, velocity, acceleration, uniform acceleration, non-uniform acceleration. We have discussed all the things in the previous videos, and also did the numericals from that. Now graphical representation means by using graph we are going to do something, by using graph. So at first let's draw the graph. So this one is a graph which is time versus velocity. Time versus velocity. I am starting from velocity time graph. This is also known as VT graph. Okay, this is also known as VT graph. So VT graph means velocity versus time graph. Now here just I am saying one thing. Tell me in the comment section that what is the area of a rectangle. If I am taking, this is 3 meter and this is 5 meter, then what is the area of this rectangle? Area of the rectangle is length into breadth. I hope you all know. So 3 meter into 5 meter, right? So 3 meter into 5 meter means 15. 3 into 5, 15. Meter into meter, it is meter square. Okay, 15 meter is not answer, 15 meter square is the answer. Okay, meter square you have to use, because you are finding the area. How it is getting? We are getting by multiplicating the units also of those two, length and breadth. Here also, if I draw a line like this, I am drawing a line like this, and I am connecting this line like this with a dotted line, just because actual motion is along this path. Okay, actual motion is means graph is not like this, that if I am drawing a line along that path the motion is happening, means along that path object is going. It is not like that. Graph shows the variation of motion. Okay, variation of motion means variation of any parameter, like it may be velocity, it may be displacement, it may be acceleration with time. So how it varies actually. See, if I take here, if I consider this is a particular instant, because it is time axis, along x axis is our time axis. Let's suppose it is starting from 0 second. It is origin point 0, 0, where velocity is maybe different, time is 0. At this point velocity is also 0, means 0, 0 point. This is why it's known as origin. Now at a certain instant, let us suppose it is 5 second and it is 10 second. Okay, 5 second and 10 second. Now at 5 second, if I go above, then it is what? It is the velocity. If it is 5 meter per second velocity, then at 5 second its velocity is how much? 5 meter per second. Again, if I go up like this and reach to this point corresponding to 10 second, then also this level, this point level is here, means 5 meter per second, also its value at that point. So fact is that in 10 second its velocity is 5 meters per second, in 5 second also 5 meter per second. If you take any other point in between them, then also 5 meter per second. Means its velocity is not changing with time. I am increasing time, I am decreasing time, but velocity is not changing. What is happening? Then this is known as constant velocity. Constant velocity. Or it is also known as uniform motion. Uniform motion. Uniform motion means what? Velocity is not changing. Where velocity is not changing means what? V is equals to u, final velocity and initial velocities are same. If these two are same, then what will happen? Their difference v minus u will be 0. If v minus u will be 0 means their difference of the velocity, change of velocity is 0, then acceleration is also 0. No change in velocity, so acceleration is 0. In case of uniform motion, acceleration is 0. Very much clear, right? A equals to v minus u by t. This is the fourth lecture. In fourth lecture we have already discussed the thing about this, that a equals to v minus u by t, a constant velocity. How we are getting constant velocity? By the graphical representation, that it is giving us constant velocity. Velocity is not changing with time. Okay, now see. In the next graph, I am going to show you the different thing. Here it is time axis t, here it is v. Now I am drawing a graph like this. Okay, let's begin with this graph. I am drawing a graph like this. This is simply a line, straight line, which is going through origin point, right? This is origin point. Now fact is that if I take any point here, let's suppose it is 5 seconds, since it is time axis, so at 5 seconds it is having some velocity, means if I go above, it will touch here, and it is parallel to this one, so obviously this will give us some value, let's suppose v1, or it may be some numerical values like 2 meter per second, let's suppose 2 meter per second. Go to 5 to 10 second, means you can see this gap is same. If it is 5 second, it is how much? 10 second, gap of 5 second. I am going again above it, and this point is parallel to this one. It is 2. It is how much? You can see if it is 2 meter per second, it is also 2 meter per second, because gap is almost same. Again, if you go to 15 second, it will be parallel to this line, and it will come to the again this is 2 meter per second. So basically it is the level of 2 meter per second. It is the level of 4 meter per second. 2 plus 2 4, and 4 plus 2 is how much? 6 meter per second. So at this point, at 5 second, its velocity is 2 meter per second. At 10 second, its velocity is 4 meter per second. At 15 second, after 5 second gap is there, it is 6 meter per second. So what is happening? Its velocity is increasing with time. You can see at 5 second 2 meter per second, at 10 seconds 4 meter per second, at 15 second it is 6 meter per second. What is happening? Its velocity is increasing. And how it is increasing? In first 5 second it is 2 meter per second, increment is 2 meter per second. In 10 meter per second, in 10 second means in next 5 second its velocity becomes 5 meter per second. So what is the increment? Within 5 second increment is 2 meter per second. Again within next 5 second its increment is how much? 2 meter per second. So constantly it is increasing. So this kind of graph means V versus T graph, and the line is parallel and line is straight line. Okay, line is straight line means this kind of graph. Actually this kind of graphs, here it is velocity, here it is time. This is straight line graph. This indicates that velocity is changing. No problem, velocity is changing, but that change is constant. If velocity is changing and that change is constant, here it was 2 meter per second, that change is constant, then obviously acceleration will be constant, because acceleration equals to v minus u by time. It is also what? Constant. So this kind of graph, when someone in exam it will be asked that what is the graph represent? This is uniform motion, non-uniform motion, what is happening actually? So this is non-uniform, this is the motion with constant acceleration. Velocity is changing, non-uniform motion. Okay, when velocity is changing, then the motion is not uniform. Uniform motion means constant velocity. Okay, so velocity is changing, but constantly it is changing. Okay, within 5 seconds, if it is changing 2 meter per second, then next 5 seconds it is also fixed. Now let's come to establish the equation of motion. I hope up to this the graphical representation is clear to you. Now next thing is I am just going to prove some theoretical things. Okay, like this one is v, velocity, this one is t, time, and I am drawing a graph. Here it is starting from this position, and so let's make it like this. Initially means when t was 0, means time was 0, then velocity is initial velocity, starting velocity, which is u, let's suppose. And after some time, how much time? After some time t, means here it is t. After t, its velocity becomes v. Okay, so this point is v, means distance from here to here, it is v. Okay, distance from this point to this point, it is v. If I join this line like this, then this is u, right? This is also u, this is v. Now what is the value of this one? What is the value of this one? That is v minus u. Simple, v minus u, v minus u. One thing I have said, that area of a rectangle is 5 meter into 3 meter, length into breadth, 5 into 3, 15, meter into meter, meter square. I have said this one. Why I have said this one? See, if you find out the area of this graph, means if you try to find out the area of this particular region, then what will be the area? See, for if the graph is like this, I am again going to this one. If the graph is like this type, then for this case I am getting a rectangle. For this case I am getting a rectangle. This is v, velocity. By the unit I am saying meter per second in SI system. It is time, which is having some unit second. If I want to find out the if I want to calculate the area of this graph, then this is time. This is time axis, so length is time, and breadth is how much? That is velocity, means v. Obviously unit we have to put, it is t second, it is v meter per second. What is the area of this graph? Area is simple, length into breadth, v meter per second into t second. V into t, that is vt. Meter per second means what? Meter by second into second. So second after cancelling this, you will get vt meter. Vt meter, meter is the unit of what? Displacement or distance. Since I am taking velocity, so we need to consider it as displacement. So displacement, how we can calculate? Displacement we can calculate from vt graph, velocity time graph, and for vt graph, its area gives us the concept about displacement. About what? About displacement. So area of vt graph gives us what? Displacement. Means if I similarly, it is also vt graph, but here the motion is not uniform motion. It is non-uniform motion because it is moving with some constant acceleration. I have already said acceleration means what? Change of velocity v minus u by time, but it is constant, it is fixed for this kind of motion because it is a linear motion, straight line motion. Okay, because it is in straight line I am getting. So here you can find out t equals to v minus u by a after cross multiplying. So this kind of things you can easily find, and also v equals to u plus at, right? This kind of things you know already because in the last class I have discussed. On the end screen or on the description box you will get the link of that video, okay, or comment section you can access the link of the previous videos. Now v equals to u plus at, this is the velocity, this is the final velocity I am getting. which depends on the initial velocity, acceleration and time. Now area of this VT graph, will give you what? Displacement, and this displacement is denoted by S. Is how much? Now we have to find out the area of this portion. So area is half into, this is the shape known as trapezium. You know this shape is known as trapezium, this kind of trapezium, this trapezium. What is the property of trapezium? That any two lines, any two opposite sides are parallel. Any two opposite sides of a quadrilateral is parallel. This is the condition of trapezium. Now here, why is it trapezium? Because this line and this line are parallel, these two lines are parallel. Okay, so what is the formula for area of a trapezium? Formula is half into sum of parallel sides. So sum of parallel sides means this one plus this one. So this one is u and this one is v. So sum of parallel sides means u plus v into time. So displacement S is equals to half into u plus v into time. So S equals to half into u plus v into time. Time means how much? Time means you can put this value v minus u by a. Now just simplify this thing. So 1 by 2a into v minus u into v plus u. V minus u into v plus u, a plus b into a minus b like fillings. So v square minus u square. Now 2as equals to v square minus u square. What is the value of v square? V square I am getting u square plus 2as. So the value is v square equals to u square plus 2as. This is the second formula. First formula I have already said that this one is the first formula of equation of motion. This one is the second formula I am getting from this relation, from the area of this graph. I am just calculating the area of this graph and putting the values of different parameters. Like here I have put the value of t as v minus u by a. Similarly, if I want to put the value of v instead of t, then what we will get? So S equals to half into u plus v into t. It is the formula. Now if I put this value v equals to u plus at in this equation, in this place of v, what will happen? S equals to half into u plus v means u plus at into t. Now multiply, so half into 2u plus at into t. Again multiply, half into 2ut plus at square. I am multiplying at first with t, then half multiply with half, so it will be ut plus half at square. So displacement S I am getting S equals to ut plus half at square. So how much formulas, how much values I am getting, how much formulas? That is, at first I am getting v equals to u plus at. First formula, v is equals to u plus at. This is first equation of motion. Second is equation of motion, v square equals to u square plus 2as. Third equation of motion, I am getting S equals to ut plus half at square. So these are the three formulas. One interesting thing is there. What is that thing? You can see for the first formula there are total 4 parameters, v, u, a, t. In the second also v, u, a, s. Only 4 parameters. Here also s, u, t and a. See, in both these 3 equations, these are common, u and a. So when you are going to solve or calculate the numericals, during that time, if initial velocity and acceleration, these 2 things is somehow known, then it is very much easy to calculate that problem, very much easier. Okay, so basically v equals to u plus at, these three are the formulas where u and a terms are common, and also most vital parameters are those u and a. Okay, this is the main fact. Now, so u and a, these are the main things. So in the next class we will discuss more about the graphical representation I have completed, and all the things related to graphical representation I have done. And this was and in the next class I am going to discuss more about the about these laws and what will happen in case of gravitational acceleration, what will happen in case of retardation. Okay, this kind of things I will discuss in the next class. So I hope this video is helpful for you. Next class will be very much important, because I am going to discuss there about the numericals and how we can use these formulas there. Okay, this is the next this will be discussed in the next class. If you have any doubt, you can leave a comment on the comment section. Okay, thank you.